Chapter 3.1 Solving Quadratic Equation Algebraically. A quadratic equation in one variable is an equation that can be written in the standard form ax squared plus bx plus c equals 0. So just remember the vertex form was a times x minus h squared plus k, and the standard form quadratic equation is ax squared plus bx plus c. A root is also called x-value or x-intercept. A root of an equation is a solution of the equation. They are also called the x-intercept of the equation. Example number 2, solving quadratic equation by graphing. So I'm going to graph each equation on Desmos, and I'm going to get the graph from Desmos and copy it over here. So please graph this equation on Desmos and then see where are the x-intercepts, because that's going to be our solutions. So this is the graph that I got from Desmos, where this is the point vertex and this is y-intercept. Now our aim is to find x-intercept because that's going to be our roots or solutions. So this is the point and this is the point where we have an x-intercept. So our x-intercept is going to be 3 and -2. You can also write it in a point form. So it's going to be 3 comma 0 and -2 comma 0, or you can just write 3 and -2. So for letter B, I turn this equation into this form by subtracting 4x on both sides. So it's going to be -2x squared minus 4x minus 2. I graphed it from Desmos, and the graph that I got is this one. Remember, this is going to be a negative, which is opens down graph by the factor of 2. So 1, 2 over 1, because a is 1. Now if you notice that this graph is going to meet the x-axis at only one point, that is -1 comma 0. So that's -1 comma 0. So x-intercept is -1 comma 0. Now you would wonder, where is the second x-intercept, because there is going to be two x-intercepts always if it's a degree 2 equation. So if it is a degree 2 equation, you're going to have two solutions. If it's a degree 1, then you're going to have one solution. Again, if the exponent is 2, then we should have two solutions. Anytime from the graph, if the graph touches the x-axis and come back, it means that is a repeating x-intercept or repeating root. Means that the same number will be listed twice as a solution. So -1 comma 0 and -1 comma 0. So you can also write that this is a repeating root or repeating solution. X equals -1 comma -1. So that's how you can write the solution. Again, it's going to be a repeating solution anytime the graph goes and touches the x-axis and come back. If it is cross the x-axis, then it's going to be a one solution. So now when I graph this equation on Desmos, the graph that I got is this one, where the vertex is 4 comma -4 and the x-intercept is 6 comma 0 and 2 comma 0. So our x-intercepts are going to be 6 and 2. So you can also write that the solution is 6 and x equals 2. So there are going to be two solutions. Remember, when it's cross the x-axis, then you're going to have one solution. If it is touches the x-axis and come back, then that point where it touches is going to be two solutions. Now the graph that I got from graphing this on Desmos is this one. Now this graph, it touches the x-axis at only one point. It means that one point is going to be your repeating root. So that point is 1.5. So our x-intercept is going to be 1.5, 1.5. You can also write these solution as x-intercept, that is in a point form. So it's 1.5 comma 0, 1.5 comma 0. Next is, when solving quadratic equations using square roots, you can use properties of square root to write your solution in different forms. When a radicand symbol is the one that is a square root symbol. When a radicand in the denominator of a fraction is not a perfect square, you can multiply the fraction by an inappropriate form of 1 to eliminate the radical form from the denominator. The process is called rationalizing the denominator. Example number 2, solving quadratic equations using square roots. Solve each equation using square roots. So we're going to solve for x for letter A. So first thing is to isolate the x squared term. So isolate by adding 31 on both sides. Going to get 4x squared equals 80. Now in order to solve for x, you're going to isolate the x term. So divide both sides by 4. You're going to get x squared by itself. On the other side, you're going to get 20. Now to solve for x squared, we're going to use its opposite operation, that is square root. So square root is the opposite operation of square, and you're going to take square root on both sides. So you get 2 and 2 cancel, and on the other side you get plus or minus square root of 20. Now you break square root of 20 into 2 times 3, and if it makes a pair, take one number from each pair outside of the radical symbol, and that will be your answer. So it's going to be x equals plus or minus 2 square root 3. For question number B, you're going to subtract 9 on both sides. So 3x squared equals negative 9. Divide 3 on both sides, you get x squared equals negative 3. Now you're going to take a square root on both sides. You get here plus or minus square root of negative 3. On this side, the square and square root cancel. So you get x equals plus or minus square root of negative 3. Now I'm going to introduce a new thing, that is negative 1 square root is I. So you're going to break this as negative 1 and 3. So negative 1 times 3. Now negative 1 square root is I and square root 3 as is. So the answer is x equals plus or minus I square root 3. For the next question, you're going to remove the 2 over 5 from the square term. To remove the fraction, we are going to multiply the opposite of that, which is a reciprocal of 2 over 5, and that's going to be 5 over 2. So you're going to multiply 5 over 2 both sides, and in this case 5 and 2 cancel. So you get x plus 3 square equals 25 over 2. Now take a square root on both sides so that you can cancel the square and the other side become plus or minus 25 over 2. So this side 2 and square root cancel, x plus 3 equals plus or minus square root 25 divided by square root 2. Now subtract 3 on both sides, you get x equals negative 3 plus or minus square root 25. And now we are going to do the step to rationalize the denominator. So you're going to multiply to top and bottom, and it's just like multiplying 1 or a big 1. Square root 2 over square root 2. Square root 2 over square root 2 is 1. So it seems like that you're multiplying 1 with this equation. Why we multiply with the square root 2 and square root 2? Because on the bottom it becomes square root 4, which is 2. So the answer would be x equals negative 3 plus or minus square root 50 over 2. So remember, square root 2 times square root 2 is just 2. So if you multiply same square root twice, then the answer would be a number without a square root. Now you're gonna pause the video and do 1, 2, and 3, and then check your answer again. For number 1, you're going to isolate the square term, so minus 1 on both sides. You get negative 2x squared equals negative 7. Divide with negative 2 on both sides, you get x squared equals 7 over 2. Now you're going to remove the square, so the opposite operation is taking square root on both sides. So you get square root of x squared equals plus or minus square root 7 over square root 2. Now we are going to remove the square root 2 from the bottom. So we are going to do the rationalizing the denominator by multiplying the same number top and bottom, so that square root 2 and square root 2 become 2, and on the top you get 7 times 2 and 14. So square root 2 times square root 2 is 4, so square root of 4 is 2. For number 2, you're going to, the square term is already isolated, so you're going to take a square root on both sides. So you get here p minus 4 equals plus or minus 7. So square and square root cancel. So you get p minus 4 equals plus or minus 7. So plus 4 on both sides, you get p equals 4 plus or minus 7. Now if you look this carefully, there are going to be two expressions here. One is 4 plus 7 and the other one is 4 minus 7. So it means that you're going to get two answers, that is 11 comma negative 3. For the next question number 3, you're going to isolate the square term, so which means that subtract 14 on both sides. You get 2 over 3 x squared equals 6. Now you're going to remove the 2 over 3 by multiplying its reciprocal, that is 3 over 2 on both sides. So 3 cancel, 2 and 2 cancel. You get x squared equals, that is going to be 6 times 3, which is 18, divided by 2 is 9. So take square root on both sides. The 2 and square root cancel. X equals plus or minus 3. So square root of 9 is 3.